Hello everyone, my name is Al-Bara Al-Ghazali and today I will be presenting a lesson of simplifying rational functions and radicals. This topic is an important part of algebra and understanding how to simplify these expressions will help you success in later topics like advancing functions and problem solving. Throughout this presentation, I am going to show you what rational and radicals expressions are, why we simplify them, and how to simplify them step by step. My presentation will cover the following: what rational functions are, how to simplify rational expressions, what radicals are, how to simplify radical expression, how to combine both concepts in mixed expressions. Now, what is a rational function? A rational function is a simplified one polynomial divided by another polynomial. The general format looks like this: fx equals px divided by qx. The key rule is that the denominator qx cannot be 0 because division by 0 is undefined. Rational functions shows up a lot in algebra when we work with graphs. Being able to simplify them correctly helps us understand their behaviors and solve problems more effectively. Yuck. Why simplify rational functions? There are a few reasons why simplifying rational expression is important. First, it helps us identify any restrictions. These are values that makes the denominator equals 0. Next, simplifying allows us to cancel common factors, which make the expression easier to work with. And overall, simplifying makes evaluating or graphing the expression much more simpler. These skills also connect directly to working with functions in later math courses. Steps to simplify rational expressions. Here are the steps to simplify rational expressions clearly and logically. Step 1. Factor the numerator and the denominator completely. Step 2. Identify the domain restriction. These are values that make the denominator equal 0. Step 3. Cancel. And now, step cancel any common factor that appears, both the numerator and the denominator. Step 4. Rewrite the simplified form. Following these steps ensure the answer is correctly and expressed in its simplest form. Now let's hop on to example 1. Simplifying a rational expression. In this example, we want to simplify the expression x squared minus 9 divided by x squared plus 3x. First, we factor each part. X squared minus 9 becomes x plus 3 or x minus 3. Because this is a difference of squared, x squared plus 3 squares becomes x plus 3. Now we cancel the common factor, x plus 3, on top and bottom. So the simplified expression becomes x minus 3 divided by x. Now finally, we need the restriction. X cannot be 0, and x cannot definitely be minus 3. These are the values that would make the original denominator equal 0. Let's hop on to slide. What is a radical? A radical is an expression that includes a root symbol, such as a square root or a cube root. Some examples are root x and root 50, or the cube root of numbers. Simplifying radicals is important because it's helped us write expressions in their cleanest form, which is especially useful when we later combine radicals with rational expressions. Expand. Check. Now, rules for simplifying radicals. To simplify radicals, we follow a few simple rules. First rule: break the number or expression into prime factors or perfect square. Look for pairs of identical factors when dealing with square roots. Each pair can be pulled outside the radical as a single number or variable. Whatever is not paired stays inside the radical. These steps help us express the radical in its most simplest form. Example 2. Simplifying root 72. Let's simplify the square root of 72. First, we factor 72 into 36 and 2. We choose 36 because it's a perfect square. So we rewrite the expression as square root 36 times 2. Next, we take the square root of 36, which is 6, and that moves outside the radical. This 2 stays inside the radical because it's not a perfect square. So the simplified expression is 6 square root 2. Now let's hop on to example 3. Example 3, simplifying root 12 to the x to the power of 3. Here we have a radical that includes both a number and a variable, square root 12 x to the power of 3. First, we factor everything inside the radical. 12 becomes 4 times 3. X to the power of 3 becomes x squared times x. So now we have square root 4 times 3 times square x times x. The square root of 4 is obviously 2, and the equation root of x squared is x. So those moves outside the radical. What remains inside is x, 3x. So the final simplified expression is 2x root 3x. Now, combining radical and rational expression. Now let's look at how radicals and rational expression work together. Here we have square root 45 divided by square root 5. So we can combine them into a single radical. Square root 45 divided by 5. 45 divided by 5 is 9. The square root of 9 is 3. So the entire expression simplified neatly to 3. Now let's hop on to the more complex example. In this example, we want to simplify x root 50 divided by 5 root 2. First, we simplify square root 50. 50 is 25 times 2, so square root 50 equals 5 square root 2. Now, substitute this back into the expression. We get x 5 square root 2 divided by 5 square root 2. The 5 square root 2 cancels out completely, leaving us with just an x. This example shows how simplifying radical can help us make rational expression so much easier to work with. Now let's hop on to the summary. To summarize, here are the main ideas for today's lesson. Always factor the numerator and the denominator when simplifying rational expression. Identify the domain restriction based on the denominator. Cancel only common factor. Break radicals into perfect squares or pairs. Rewrite the simplest, most radical expressions. These skills will help you handle more complex algebra expression and prepare you for the math classes. So thank you for listening to my presentation on how to simplify rational functions and radicals. I hope this helps you understand how to simplify these expressions and why the process is important. If you have any questions, feel free to ask.